And so a 3, where we say children 3, has position 0, position 1, and position 2. That's just how computers function. The thing is, with C++, there is this protection of this what we call pointer within the array, because literally what it does is it's going to point you to this memory address location. So where you have a 2-byte type variable, and so address 1023 and address 1024 hold position A0. Then 1025 and 1026 has A1. 1027, 1028 has A2, and so forth and so on. This, because of the fact that C++ does this, and there's this interrelation within memory, hard-coded in memory. And because of that, that is why we say that C++, there's some things in C++ that we need to be very careful of. And we're about to look at that now. All right, so we were just looking at that slide, so let's jump on over into this one. Now, first of all, the concept of auto-initialization. And auto-initialization says that if I initialize an array and I say A10, that means that I should have position A0 all the way to position A9, correct? All right. So if I put values in to position A0, then put values in position A1, and then put values in position A2, what does it say here? It puts a 0 of that type. So if it is an integer, it's just 0. If it is a floating point or a rational number, then it's 0.0. And, going on and on like that. Now, we can use what we call implicit initialization, which means that you could leave the size out. And you could put an array into a program and then put that array into a loop and then have the program fill the array. And then when the program is finished filling the array, then the program, then the computer, closes off the array at that end point with that last variable. The thing is, avoid doing that at all costs. Try to find out a way to get a reasonable size and then have the computer truncate things down, as opposed to doing it the other way. Because memory management in C++ is a serious thing, and can cause C++ to start interfering. Your applications that you write in C++ can start interfering with other applications that are currently running. All right. Now, our next consideration is arrays in functions or subprograms. First of all, when you have an array as an argument in a function, it can be an indexed variable, where an individual element of an array can be a function parameter, or you can have, basically you're saying we're passing A10 or we're passing A7 of a 10 space dimensioned array. We're passing element number A7 in a function. You could do that. Or sometimes you can pass the whole entire array as one entity. And you can also put a return value of the whole array or a single element, either one, back from a function. You can do either. but you're going to find that in many instances, it's going to be, you will find yourself passing a whole array. It's like saying, I'm going to pass the student grade book from this class into a subfunction, and I'm going to do an average. Well, what I might as well do is create an array with all 14 persons registered in this class, and then pass that whole 14 function, whole 14 position or 14 member array into a subfunction, and have that function calculate the average, and then pass me back one value, or just pass me back not only the array, but another array that has the standard deviation across that from the mean. So you see what I'm talking about? Okay. Hold on. Where we go? Right. Okay. Now next one. Yeah. So we can have the index variable handled the same as simple variables. So you can call A7 and work on A7. So right here it says, okay, given this function declaration, we have void my function, and it is using a double, which is power 1. And then we have these declarations, integer I, double N, and then A10. Now, all of them, well, actually, no, this is going to give an error, because first you're going to have a integer, which is I, and then, oh, okay, I get it now. He's got, what he really should have done is that. And then you have the double precision real number of N, and A10 is full of double precision reals. Let me drag this up a bit so that it looks. So that it looks sensible. Okay. All right, now, so you could therefore then, when you have this function, which is called my function, right? Which is taking some double precision and some variable here. I can either be calling some value, and that value could then be converted to a double in the function call operation, or an existing double, which is a 3 from this 10. Okay, somebody's asking a question. After class. Yeah, sure. Okay. Right. And yeah, and then the same thing with just a discrete variable itself. And so what will happen is that variable itself will, whatever the value of that variable is going to be passed over into that function and called into that function, and that function will operate on that variable. Now, some subtleties with regards to indexing. So first, we have this my function, and then we have two variables, a and I. All right. And the value of I is first determined. So you may be in a for loop where I equals 0 to 10 or something like that, right? So it finds out what I is, and then it determines what A to that value is in the array. You could also perform what A to the I times 5. From the compiler's point of view, that is perfectly legal. But from the programmer point of view, you got to be very careful with that, because, hey, if I is going from 1 to 10 and A is dimensioned, well, if I is going from 0 to 10 or 0 to 9, sorry, and A is dimensioned as a 10-member array, then I times 5, anything past 2, is going to put you out of bounds. So that becomes very, 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 very dangerous thing to do, while the compiler is going to see nothing wrong with it. So just understand that. Well, we already talked about this. The formal parameter can be an entire array argument. And you can send the size of the array down later as a second parameter. And so we're doing the same thing here. So we have something called fill up, where you have A and just a block. It's got implicit declaration going on here, and then you have size. And so we name we set up size as a number, which is going from, we say, okay, enter, and then you have size, and then we go from I to size, and it's going to go from 0, 1, 2, 3, 4, and it's going to basically accept these values based on whatever the number is in size. Okay, and then the last array index used is, of course, it's going to be size minus 1, which we already know about. All right. Okay, so we've looked at that. Given the previous example, in some main function definition, we consider the following calls. We have score 5, where number of scores equals 5. So we're basically declaring an array called score with 5 positions, 0 to 4. And then we have number of scores as an integer called 5. And then we have a function called fillup. And fillup is going to define a variable called score and then number of scores. And so therefore, it's going to be accepting discrete singular values, right? Even though the first argument is the entire array and the second argument is the integer value. All right, so notice that there's no square brackets here. So in this case, what it's actually going to be doing is it's grabbing all 5 of those from 0 to 4, and as a loop, how should I put it? As a group, and filling them in memory for that. Okay, and so this is how it is. This slide here, very important. What is really passed? Think of an array as 3 pieces. The address of the first indexed array. So that's array name 0. Then you have whatever the type of the variable is, and then you have the size. So you got its first location, what type it is, and the size. The first location tells you where it starts in memory. The type then is really a multiplier, because if it's a regular short integer, it's going to take up 1 byte of memory, 8 bits. But if it's a long integer, it's going to take up, it's going to take up two bytes, which is going to be 16 bits. And if it's a long integer, it's going to take up 16. It's going to take up 4 bytes, which is going to be not 16, but 32 bits. All right. And then you have the size of the array, which then tells you, based on what the multiplier is in the array-based type, how we're going to then multiply that size to partition and set aside a lump sum of memory. Okay. And so, yeah, so only the first piece is passed, because all the others can then be calculated and inferred, because that's what a computer does. It just starts adding one address and then one address and just keeps on going. All right. These array parameters. First of all, it may seem strange that we use no brackets in the array argument when we pass in the whole array, and the fact that we must send the size separately. But what makes this interesting and what makes this nice is because we could basically use the same function, and we're not pigeonholed into, okay, the first array was a 10 element array. So now that I'm dealing with a 50 element array, I got to write a function. No, because of this implicit declaration, the same function, no matter what, can calculate the average of a 50 element or a 5 element or a 10 element, doesn't matter. Okay. And so you can basically just reuse those. Okay, the constant modifier. Recall that in our array parameter, it actually passes the address of the first element. And so the function can then modify the array. And so again, this is where C++ can be very powerful because your C++ functions can then start modifying when you have, if you have a C++ program embedded in an HTML page, that C++ program can start to do things like saving someone's credit card someplace else and saving someone's personal information someplace else and doing these kinds of things. So this is why we say that C++ is a very powerful language, especially in the way it deals with arrays, as opposed to these other languages where all of this stuff has to be explicitly defined and the size of the array has to be explicitly defined and so forth. And this type of power does not exist. And this is why C++ programs are one of the, how should I put it, red flags in email antivirus scanning software and C++ programs embedded in web pages are also red flags when we look at safe browsing and like in McAfee and some of these others, Norton's, where they have their internet, what do you call it? Internet security packages. And so with the internet security, they're looking at web pages, and one of the things they're doing is they're looking for C++ constructs. And when they find a C++ construct, a red flag is raised because they know that when you start recognizing C++ calls and C++ modifiers and constructs, you have the ability to do some very dangerous things. Okay. Now, how can you protect your customers from the modifications? You can use the constant before the array, which then causes the computer to affix whatever value is in the array and is going to make that value stay there and no subsequent modifications can be made. So that is that's something that can help you to write safe programs. And so now, functions cannot return arrays in the same way that simple types of integers and logicals and double precision reals and so forth. It requires the use of a pointer, which we talk about in a later chapter. But basically what it's going to mean is you're going to basically need a for next loop, which is going to then do a return for each one of those values in the array that have been modified. And what it does is it essentially just writes that value into memory. Okay. So programming with arrays, there are lots of uses. Sorting, searching, and whatnot. We did an example last week with sorting an array. in sorting an array in ascending order and descending order. um, the thing is, with partially filled arrays, it's difficult to know the exact size. And so that's one of the reasons why declaring an array with the largest possible size is usually what you end up having to do. But you want to make sure that you don't make it so big that you got to sit there or go make a cup of coffee while your computer is loading this array in memory because you've dimensioned the array to be so big. All right. And yes, when we first moved the back then College of the Bahamas, now UB database, from the AS400 DataTel program into the original Power Campus. That data pass, we started that data pass at, I think it wasn't 5 o'clock, it's probably around 4:30 or so on a Friday evening. And basically we scheduled each member of the IT department to just come in every 6 hours and just check on it to see how the conversion was taking place, going from an IBM iSeries SQL database over into Microsoft SQL. And so yeah, there was a latency, or there was a lag from system to system, communicating system to system. But it still took us until Sunday afternoon to get that whole database. And that was people from, oh, good God. I think that database started in 1982. So that was students from 1982 going all the way to 2002. So basically that was 20 years of student data. Took a hell of a long time to process. And of course, that was everything from demographics to registration data, to grades, to graduation data. And in some instances, there would have been other mitigating circumstances, students who transferred grades, because I know persons like myself, I didn't, quote unquote, finish at UB. I transferred to Tuskegee and ended up taking Calculus 2 and Physics 2 over there because I had turned from full-time to part-time. And, you know, when you part-time, back then registration was in the auditorium and you had to race into the auditorium and get there, or all 25 seats would have been gone. So, yeah, you all have it really good being able to just sit at home and register now. But anyway, all of that just to tell you that partially filled arrays, something that can be done and you can work with relatively competently. And so slide 30, we have an example of that here. All right. Now, global constants versus parameters. Constants, well, basically, whenever something is global, it has been declared. You can have a global variable or a global constant. And once it's declared as an integer, as a whatever, above that void main, right? Then that variable, and that variable will be declared as that variable type, whether it is a singular variable or an array, it will be declared as that and would be accessible everywhere in that program, within the main and all functions. So we have here where functions then have scope to the array size constant. There's no need to send a parameter. Well, yes, why should we? Basically, we need to do so. Come on. Because when we define something outside of main, then that variable is actually available to other programs. And when we write programs, lots of times we write programs that may have sister programs running alongside it. And these variables may be global in the sense that they need to be available across all these other programs. All right. Okay. So then searching in an array, of course, we have this program here. We already looked at all of this last week. All right. Yeah. And then, right, I started to talk about multidimensional. The fact that C++ can allow you to use more than one dimension. So you can have a row of 30, then a row of 100, then a row of whatever. But essentially what this is there are 100, the way C++ does it, like it says, is what this is saying is there are 130 element arrays called page, where you'll go from 0 to 29 for the first one, 0 to 29 for the second one, et cetera, et cetera, et cetera. And we visualize this as 30 rows, 100 columns, right? When we look at matrices. But just know that in computing, you can use more than that. It's not advisable in C++, owing to the fact that because of how C++ operates, C++ it doesn't have a fault. Because of how C++ operates, it's going to be difficult figuring out or troubleshooting when errors comes up. However, the way Java and Fortran and Basic and Visual Basic and so forth, the way they deal with arrays is a whole lot easier, and you can use multidimensional array, I'll get it right in a moment. Multidimensional, there we go, arrays in a number of ways. All right. Multi-dimensional array parameters, they're similar to one-dimensional array. If the first dimension size is not given, then the second dimension size has to be given. You cannot have a double implicit declaration. You can only have a singular implicit, because like I say, what this says is this is now giving you 100 open dimension arrays called P. And so you don't really want to get more in depth than that. Okay, so in summary, an array is a collection of same type data, just like our a matrix, right? Index variables of the array are just like any other simple variables. For loop is a natural way to basically point your way through an array. And the programmer is basically responsible for staying, quote unquote, in bounds of the array, within the boundary of the minimum and maximum. Another thing, thou shalt not dimension an array to a negative number. I'll say again, thou shalt not, unless you want your computer to explode, dimension your array to a negative number. I'm kidding about the explode, but I think you get my point. Okay? When you dimension an array, we're talking about literal. So we're talking about the 0 is the first position, and whatever that maximum is, -1 is the last position. And then next, we have array elements are stored sequentially. 0, the first position, 1, the second position, 2, the third position, et cetera, et cetera. Okay? to what they call the contiguous portion of memory. It chops out a bit of memory and slots in the data in their one by one order. The only address of the first element is passed in functions, and the function itself relies upon that data and the declaration data or the definition data of the function to calculate all of the rest that it needs. Okay. We can have things like partially filled arrays. We can have constant array parameters that prevent modification. We can have multidimensional arrays. And all right, so that basically does it for arrays. All right, so do I want to say it? I didn't change anything, did I? All right. What's left? What was I supposed to be using? I think it's chapter 9 I said I need to go to. Do I want, yeah, repair. Compatibility mode, why not? Strings. Okay, SHA variables, strings, characters. Those of you who have done any code programming before would know that there are numeric variables. There are string or variables which you do not want addition, subtraction, multiplication, division, square rooting, powering, modulus, and them kind of mathematical operations to be calculated on, even if there is a number in that space. Okay, so this is that's what we call a string. Typically, strings are used to house things like first name, last name, street, nationality, gender, and so forth, right? Yeah, anyway, that's another joke for another day. But anyhow, now the objectives, we're going to look at the array type for strings, and we're going to look at character manipulation tools, because why should we collect first name and last name and put it in a computer if we can't do things like alphabetize an array made up of last names, so second names, and so on and so on and so on. All right. So there are two string types. First, there are C strings. And so those immature persons in the class, you can stop giggling. This is an array type, which has the base SHA variable type. The end of the string is marked with what we call the null character, which is / and 0. And it is a holdover and it's basically inherited from the original C language. And they had to do it because when they first invented computers, they invented computers to use numeric variables. They divided the numeric variables into integers and reals. Then they had string variables, and the string variables, they decided to use the strings to say, all right, the string is going to be a matrix, a one-row matrix. And so my last name is Ford. So my last name would hold in a matrix that is going to go a 4-position matrix. The F is going to be in position 0. The O is going to be in position 1. The R is going to be in position 2. The D is going to be in position 3. And then there's going to be a / and 0 at the end of that to say, okay, that's all that is in that makes up this particular string. And this is a carryover from the glory days basically were
progress.
single row arrays, and then you had logicals. Okay. Now we've got a whole bunch of other stuff. They call the logicals Boolean now, and you have essentially now we got some other type variables. In some instances, there are some system variables now which are passed and available through the programming. System variables like things like where you have path verification, memory location verification, all those kind of variables, a whole lot of stuff now in the programming field. Right, and then we have the string class. And the string class uses templates, and we're going to see that as we progress through the 39 slides here in chapter 9. Okay. There we go. All right, so let's first of all start off with the C strings, okay? And we have an array with a base type, which is the SHA variable. And you can have one character per indexed variable and with an extra character behind it, which is called the null character or the end marker. This thing would use C strings. That's difficult. Okay, so if we have a SHA variable called S, and it's S10, right? It declares a C string variable to hold up to 9 characters. Because you got to be able to hold a null character that says, okay, there are no more letters to search for in this thing. Because remember, the construct of S, open square bracket, 10, close square bracket is an array. And an array in C++ has the capability to look beyond for more data. And we talked about that. Especially being able to utilize an array to peer around somebody's hard drive, utilizing a loop to then go through and start just printing out. And that's basically how keystroke loggers work. A keystroke logger is it's looking at the both the A and B register for inputs that are coming in from the IRQ address from the keyboard. And once you look at that IRQ address and then the string character coming through there, you can tell what keystrokes have been pressed. And so once you just have a for loop going from 0 to several billion, you can scan a whole hard drive and see, basically you'd want to scan memory, because to scan the hard drive would be a bit unreliable, but you could scan 4 gigs of RAM, 8 gigs of RAM, fairly easy. C string variables are typically partially filled arrays. You basically declare large enough to hold a maximum size. So you find that when you write programs, you'll write programs that are you dimension first names and last names to be 20. 20 is usually a good high end for letters in somebody's first name and last name. If you want to really go overboard and you want to make sure you catch Greeks and Slavic persons with those Slavic names that can be quite verbose as far as letters, then you may want to go to 30, or if you really want to go overboard, you could go to 40. But there's really going to be no need to do that. So 20 is the norm, established practice in computing. Any of you who ever go into a serious programming environment are going to find that practice. Right. The only difference from a standard array is going to be the fact that the array, you must insert the null character at the end of an array. Okay. So standard array SHA-10 contains high mom. And so you can see, hopefully I can blow this up. Okay, that's it. Yeah. All right, so S0 is capital H, S1 is I, it's the lowercase I, S2 is a space, okay? S3 is the capital M, S4 is the O, small o, S5, the small m. Okay. Now they notice that they have S6 is the exclamation point. Now, they didn't put the exclamation point up here. So where's my, there we go. Right. Now it lines up with what they have written there. And then after the exclamation point, you have the / and then 0. And I do not like the font that he uses, because that's a picture. All right. That wants to look like a letter O, the same O as in between the two M's. That's why I don't like the way that looks. That is supposed to be / 0. Please remember that. Okay? Not / O. C string initialization. You can initialize a C string. And you can say SHA, my message 20 equals hi there. Or first name 20 equals Nathaniel, something like that. You needn't fill the the entire array, but if you initialize the array to that value, it's going to place the, see, he has the proper 0 here this time, not the letter O. Notice the difference between that and that. Okay. You can omit the array size even, and then it's going to automatically go ahead and size the array properly. Oh, and this is not the same as this. Okay. So just bear that in mind. This guy down to the bottom is a mathematical construct, which we like to use in when we're doing our math, right? We're all familiar with doing that from our what is it, 167, 168, which is the algebra course, where you're doing things like transposes and inverses of matrices and just working with matrix math. Which one of those courses? Anybody? Because it's literally been 15 years since I've taught either of those two. God, can't believe I'm that old. Anyway, okay, a C string is an array and can access, you can index and point to any of the letters within the array, which allows you then to do some interesting stuff, which we'll talk about later on in the course. Okay. So because of the fact that you can point to the first letter, the last letter, the middle two letters, and all of them kind of interesting things, there are some manipulation tools available to you. Now you can do some relatively easy, where you can create another array, same size as the array you have, and then in that array make a mirrored image where the first position of the original array becomes the last position of this new array, and the last position of the first array becomes the first position of the new array. And you can do stuff like that. But they say be careful because the null character is a character, okay? It's like, I really want you to think of your Venn diagrams. And remember, in Venn diagrams, it's possible to have intersection of A and B, or A intersection B equals null set, right? And we know that is a mathematical fact, reality. And so in C-string manipulation, you have the null character. It's a reality. It is a character. It's just a empty character, just like how the null set is a empty set with nothing in it. Okay? So the null character is a character with nothing in it. And so you can have that space, which has nothing in it, be overwritten by a character. As it says here, it could be overwritten by Z, right? So be very careful when you do string manipulation, because if the null is ever overwritten, then all bets are off. Nobody can predict what your particular computer is then going to do utilizing the C language and that C string character. And so if they mean that when they say unpredictable results, it'll vary from IBM to Asus to HP to Apple to, it'll vary. So we don't even try to predict what it is. And even within, say, Lenovo machines, you got some machines that are Intel, some machines that are AMD, some machines. Okay, I'm not even going to go any further. It's just a whole bunch of variables that are revealed that would cause behavioral patterns. Now, when we declare the C strings, there's really no library that we're looking at. It's pretty much built into the standard namespace. But when we want to do string manipulation, then we have to do the include C string. All right. So if you want to just take C names, C strings as first name, last name, and that's all you're going to be doing with them, fine. C++ has no problem with it. But when you want to start doing things like you want to go and you want to convert the first letter, first position to an ASCII code variable, and then compare that ASCII code variable to the first letter ASCII code variable, ASCII code equivalent, of this other name to see if you could compare the two and then do a swap if one is less than the other. That causes differences. All right. And now, the string manipulations, like we say, we want to do fun things with them. And so that's why the C string library is a very powerful library. But we must realize that when we utilize the C string, there are a couple of things that we need to start, we need to look at. Okay, use. And one of the things is that the equal sign and the equivalence sign. All right. Oh, excuse me a second. No, I'm teaching class right now. No, it'd be done like probably after 8. Oh, okay. All right. Right. So C strings are not like other variables. We cannot assign or compare the values. All right. So we cannot say, okay, we're going to have A string, which is a 10 letter string, and we're going to put the letter the letters HELLO. Okay. We can basically only use the assignment. Remember, when you're taking what's on the right-hand side and putting it into the memory location of the left-hand side, we can only use that in the declaration. We must use a library function for assignment where we're doing things like string copy for a string, and we do hello. That is one of your C string functions. It sets the value of a string equal to hello. And it really says to heck with the size. It's going to just shoehorn everything in there, auto dimension it up to what it needs to, and put the null character at the end of it and does what it needs to do. Now, there will be a problem in if you have predefined, like here where it says a string is hello, and you want to put something like, what's a word that has more than 10 letters? Hippopotamus is what, H-I-P-P-O-P. O-T-A-M-U-S. Yeah, hippopotamus is 11. So you go ahead and try to put hippopotamus in there. It's going to just truncate the last S off of that variable when you go ahead and try to do a printout of that string, eh? So be aware of things like that. You also cannot use the absolutely equal to operator. In terms of comparisons, where a string absolutely equals to another string, we must use the library function if string compare of a string and another string. And then you have, if they are different, then if they are not equal, then basically this compares to see whether they are not equal. If so, then it will the how should I put it? The true comes out, and then the else is going to give you the false. As a matter of fact, let's look at this next slide, which actually explains these in a little more detail. Okay, string copy. See if I can slide down just a tad. Page 357 of the text, if you're following along there. strcpy, and you have the two variables. It copies the latter into the former. So if you have string copy 1, 2, it's going to copy the contents of 2 into 1. It does not make sure, notice it says it does not make sure that the target is large enough to hold it. It's just going to put it in there, and whatever can't fit is just going to get truncated off. String copy, target, and then source, and then of course you can have a limit where the same as the same as the string copy above, but in this case you can limit the number of characters. So if you want to strike off and find out what the someone's first initial is, and so you want to put A. Roll, G. Ford, P. Thompson, etc., etc. You can use the string copy, and you can have a new variable which will be your target. You'll have the source variable which will actually have the first name in it, and then you just have the limit. So you put comma and 1, and it'll just take off the first one. All right. If the limit is chosen carefully, this is safer than the 2-argument version of string copy. Now, they note that this is not available in all versions of C++. However, it is available in both the Cygwin as well as the, I gave you all Cygwin and what was the other one? I know, because I know some of you all, it worked.
MinGW.
Right, MinGW. Thank you, sir. Some of you all, the Cygwin didn't work and MinGW worked straight through. And vice versa. All right, then we have this concept called concatenation, right? Concatenation is when you take parts of one string and put it into another. Now, string copy, target string, source string, limit one is a concept. It is string concatenation where you're just taking one value, but there's an actual function called concatenation where we say strcat and then we put the target string and the source string. And the strcat can also do the limit function as well. Okay, and what concatenation does is you can literally take a certain part of one string and, as we Bahamians say, juke it on the end of the other one. All right, so that's a real Jonkunu concept there, where we just take a word and we just take another word or some letters of the other word and just stick it onto the end of it. String cats, target, and then source, and then limit, which is the same as the concatenation where you're just taking the whole of the source, but this time, instead of taking the whole of the source, you can limit the number of characters going from the left. So if I did string cat and I do target and the source string is, say, forward, and I say limit 1, then the concatenation is going to result in target F. All right, and so you see where this concatenation command or string cat command, strcat command, was used, where you see or can be used anyway. Some of you may be, for your senior projects and stuff like that, you write programs that may perhaps be taking values of variables and or values from sensors and then creating a file name. And then you may utilize a session number or an iteration number or an experiment number. And so you put that experiment number at the end of the file name to indicate, the date or the time or the whatever. Okay. So this string concatenation is a very useful tool. Okay. More functions. We have string length, returns an integer value equal to the length of the string. All right. And now what that is actually going to do is they already know that you got the null character. So if you want to find out, I got a 20-character variable called last name, and I want to find out how many letters is in this particular person's name. I use string length because at the end of that particular person's name, if Ford was stored in there, then in L name or in last name, value 4 is going to be /0. Last name value 0 is going to be F. Last name value 1 is going to be O. Last name value 2 is going to be R. And last name value 3 is going to be D. Last name value 4 is going to be /0. So what it does is it counts up how many positions are there before you hit that /0 character, which is the null character. And once that /0 character is found, it counts up those positions and returns an integer, 0 to whatever, between 0 to whatever. All right, string compare returns a 0 if string 1 and string 2 are the same. Retains a value less than 0 if string 1 is less than string 2. No. Oh, okay. All right. Basically, because I'm like, what the hell is he writing here? Okay. Basically, it returns a 0 if they're the same, and it returns a non-zero value if they are different. And so the caution is if string 1 equals string 2, this returns a value of 0, which converts to false. Note that this is the reverse of what you might expect it to return when the strings are equal. All right. So this is kind of a two's complement. Those of you who are in electrical engineering or who have taken digital communications, and you know about binary to or decimal to binary conversions. You know about the fact that when we utilize the two's complement for subtraction and all those other interesting things, and to find the these values, you can see now why when they say string 1 equals string 2, returning a value of 0. So all that has to do is it's going back to its digital electronics roots. Okay, and then of course we have the being able to compare or limit the number of variables, the number of values inside of string 1 and string 2 that you compare. Okay, so looking back to these functions, we have string length, often used to know string length. char my string 10, doobie-doo is put in there. And then we have cout, which is string length of my string, returns the number of characters, not including the null. Okay, remember, you don't need to put the null if you enter this. But if you, as a matter of fact, you know what? Let us experiment. Stop share. Minimize. You cannot minimize Zoom when you are recording this meeting. Like it, man. All right, let's go. NetBeans. I knew that this was going to take. Okay. Running out of time. You don't say. All right. What's my next project? New project. C++. Strings. And string manipulation. Voila. Strings and stripping it. Blah, blah. source files. Okay, let's close you guys because I don't want to confuse myself. Right, now let's open the C++ for strings and string manipulation. So C standard library is up. Oh, here's a include IOString. Simple program. Okay. Declaring the string. Okay. And then when we start to do something like So build failed. We go here. Come on, mouse over. There we go. String length was not declared in this scope. And up here we got a little, okay, note, string length is defined in header C string. Did you forget to include, see why I love NetBeans? So this is why, you know, when you get into programming professionally, oh, just gotta wait for that. When you get into programming professionally, you're going to find that the intuitive aspects of the help and the program, the troubleshooting aspects of the troubleshooting aspects of the NetBeans IDE is really going to save you a lot of time, and I think I would have a whole lot less gray hair on my head if I had had the benefits of the NetBeans IDE in my youth. But back then, all we had were these huge textbooks, and having to be up all night coding and coming up against problems in code. But then again, programming itself has grown over the decades. IDE developers of IDEs themselves have learned from all of the troubleshooting, the collective troubleshooting knowledge of programmers who have assisted in in just lending their expertise and sharing their experiences. And this is what I found. This would be helpful if we did this, and this would be helpful if we did that. And so this is how programming has become a whole lot more sophisticated. And to be quite honest, in nowadays, we have the quote unquote metaverse, right? The metaverse would not have been possible 10 years ago, not just in terms of the computing capacity or even the internet speeds and whatnot, but the wealth of programming knowledge simply wasn't there. Programming as a field of endeavor was not mature enough to handle, because I'm quite sure that dream of the metaverse, a lot of persons were dreaming of such a construct. The movie Tron, of which you all probably are familiar with the remake, but as a high school kid, I watched Tron went over by a friend's house who had a satellite dish, and we watched Tron on HBO, and oh man, what a cool movie, and all of that. But it was so to us then, that was so far into science fiction, and so obviously science fiction, but we didn't dream that one day such a thing would be possible. And so this is why, as scientists and engineers, it's always good to keep your mind's eye open to be able to dream, because as science itself progresses, and I shouldn't say science, as the general body of scientific knowledge progresses, a lot of doors open up to what could be done, and what realities become realities of yesteryear that get set aside, and new realities are formed. All right, less than 1 minute. Okay, if you say so. Let's carry on until we get bumped off again, and then we'll come back on. All right, so yes, we did this string length. Yeah, okay. String concatenation. All right, so so we have this easy example here. And oh yeah, they say be careful, incorporate spaces as needed. So what I'm gonna do is, let's go back into NetBeans, and
recording in progress.
Good, and I hope you're following along and trying to make these. So this time we're going to do a char L name 20 So we got Char name, L name, and Char, L name, Leibowitz. All right, so this person's name is, and then we put the first name, the name has letters, and then we're gonna say, see out. This person's full name is, right? And so how should that look? What I'm going to do is I'm going to wait for you guys to write that. Put that in your NetBeans. And then we're going to see, then we'll see what the output is. I want us all to see what the output is one time. I don't want you to just be watching me code here without you having the benefit of being surprised or not surprised and confirmed and get a chance to have that lovely smug look on your face that we all like to get when we know something is going to work. All right, so how's everybody looking? I mean, I know I just type fast, but you should be able to get some of this stuff in so far. Anybody got any results? Okay, so after Leibowitz, I should have had a semicolon.
When I run it, the first and last name coming together.
Mm-hmm. Okay, so you got to be careful in terms of the use of the whole concatenation exercise. Now, here's an interesting. Let's try something here. Let's see if we can double concatenate. Okay, so it definitely has a problem with that. Come on. Okay, so we cannot use the concatenation of a concatenation, all right? Even if we were to say, put that there, actually, I wonder if that'll work. Just out of curiosity, no, oh, all right, no, that won't work. Yeah, all right. So the concatenation, got to be careful with respect to that. Okay. You must, it has to have two. Okay. So what you might want to do is come up with a third variable. And let's say char print of 20. And this is equal to the string concatenation of and then we put, instead of L name, we put print. Oh, wait. Print is an actual function. New var. Let's do that. Almost got ourselves into some problems there. All right, let's see whether it'll stick So this particular function isn't going to work in terms of the string concatenation, being able to stick a space into the front of that variable. But maybe instead of putting the space in front, let's see what happens if we put f name See, there's always new way. So then L name. There's always more than one way to skin a cat. So let's just try to see the options. Array must be initialized with a brace enclosed initializer. I don't believe that one little space. Yeah, I did have a problem with that. Okay, hold on. See out. New var. Let's see what happens here. Hmm. Yeah, that's the double quotes. What's this? Hmm. Because the concatenation we should be able to do an explicit, like on we should be able to do this string cat. Okay, where we have the variable, we should be able to just put that in there as a function. Oh, let's try. Where are you? Where are you? Let's do cout and that. All right, let's see if line 27 still gives us, now that I've put it as a part of a cout. Okay. Okay. Now let's take out son of a biscuit. Okay, all right. So so you see where the subtleties of C++ comes in. So now we gotta figure out all right. Okay. I don't need you no more. Give me back my code. Now, what was this new var? I don't even need this anymore. And right, don't need you because I'm gonna do this person's full name is string cat. First name. Then L name. Okay. Yeah. And there we go. Now, what I'm interested in knowing is what if I took out string cat, control X, left F name in there, and then did control V, string cat, but then instead of F name first, put the space first, control X. Hey, come on. Control V, comma, L name. Oh, no, I do not want sticky keys. No. Close bracket. There we go. Error request for member L name, and then which is a non-class type constant string. Oh, why do I have a decimal instead of a comma? Why? Build fails. Okay. Something happened. Okay, something's wrong. It is not possible to limit these functions to a maximum. Oh, yeah. Okay. All right. We can put it at the end. We can concatenate onto the end, but we can't. Your mother wears army boots. Okay. Okay. So basically, this is telling me that C++ forbids converting a string constant to char. Basically, what I'm doing is the space bar is a constant, and so I'm now concatenating the constant of a space bar. All right. Yeah. So it just and you see where it's always good to play around because the nuances in the programming can be can trip you up, and doesn't matter how long you've been coding in a particular language. Sometimes every once in a while something's going to come along and just trip you up, and it's going to be something different. But yeah, that is this guy here. Anyway, this person's. So if we go ahead and put string cat, put that back here. S name, and then take this out. Good. All right. So we should be back. Oops. Yeah. Okay. So we should be back to a running and fully working program. Yeah. Okay, so recall that C string is an array. So C string parameters is an array parameters. These can be passed to functions and can be retrieved from functions. And like all arrays, typical, we must send the size as well when we're calling to a functions. All right, the function could also use the null to find the end. So it's not necessary if the function itself isn't actually going to be changing the C string itself. All right, we can output with an insertion parameter. Well, you guys already saw this. Input with an extraction parameter. White space or tab or space bar, line breaks, they're basically skipped. Input reading stops at any of these delimiters, the space bar or anything like that. You want to watch the size when you're using the cin parameter, because make sure that, of course, you make sure you're typing in what can fit in the array. Okay, so we got some examples here. If we want to mess around with this particular aspect, okay, so let's so and I don't want to do 80. I'm going to do 810 and comma B10. Because if you do 80, there's a good chance things could slow things right on down. All right. So so we got A10, B10, and then we have C out. Please enter 2 names. And so you're gonna have CN, A, and B, semicolon. And after we have that, let's verify the inputs. And we're going to say C out. You have entered a and put a space before and a space after. And B. Now, just now I put an enter after each name. Now let's try run it again. And I'm going to say Lana space Penny. So I hit space just now. And lastly, Lana tab Penny.
Could you share the screen that you're on? We are seeing the PowerPoint, I think.
Ah, man. Okay. I did not realize. Thank you so much. Okay. Say it again. Well, that means you guys didn't see the code manipulation that I did. So that's what I typed. So instead of doing the A80 and B80 that the slide is doing, which is going to set up a really large, basically 10 bytes of 10 whole bytes of memory, which to me don't make no sense. So I'm just going to do A10 and B10. And so that's going to be basically 2 bytes each. And so I got C out. Please enter 2 names. And then C in A and B. And then I say you have entered A and B. Now, with this, you'll note that And I'll give you a chance. Oh boy, 7 minutes. I'll give you a chance to type this in. Well, we run out of time. So I typed in, first of all, Lana, and then I hit the enter key. It goes down to the next line, and then I say Penny. Okay. Then when I hit enter, notice what it runs. It says you have entered Lana and Penny, and the and is separating A and B. Okay. Now I'm going to run it again. Remember, last time I used the enter key. Lana, spacebar, Penny, and then enter. You have entered Lana and Penny. Notice Lana is sitting in the A string and Penny in the B string. Lastly, Lana, tab, Penny. If I hit tab again, once I hit enter, you have entered Lana and Penny. Okay. So that is the verification of what the author was talking about here when he says that underlined portion could be typed. Hold on. Right. Tab, space, even line breaks. They can be used to skip over into the next variable. And so the input reading stops at any of those delimiters. So a delimiter is kind of like I am finished entering for this variable kind of thing, as opposed to saying, and that's why the space is not acceptable as a value. And we were seeing that in C++, couldn't put the space in, it couldn't put the space when it was doing the concatenation it couldn't concatenate onto a space, but it could have concatenated a space at the end of first name. So again, that was one of the little quirky aspects of programming that I wanted you to be aware of. You can receive an entire line because it is a string and a line of text with numbers and letters and all that good stuff. And there is you can have a character variable called A, and you can use the get line function, which basically allows you to just go ahead and do a whole bunch of typing. And then once you hit enter at the end of the line, quote unquote line, then you've that input would go to the output. All right. And so all right. And let's see if we get some more of the stuff, more get line. All right. Well, this is kind of straightforward. Okay. Character IO is really where I want to really start getting. Okay. So input and output, we basically treat everything as a character, and then you got to go ahead and change and convert. Some of these conversions are done automatically, but some of them we basically have to force these conversions. In the get function, we read one character at a time. And the get function could be used. You'll find that, later, next week can be the last week in the course anyway, because the final exam is going to be the following week. We got to schedule that exam either on the Wednesday of Holy Week or Monday, Thursday for the final exam. But basically what we're going to do as a final exam is we're going to have a final project, which I will give you all. I'm going to give that to you guys next week. It's not going to be a long, like final term paper, but it's just going to be a final project, which will be kind of a capstone activity. But yeah, so we got the get function, we got the put function, which operates with the C out. The get function could be used to read not only from the keyboard, but from the mouse, touch screen, Ethernet cable, Wi-Fi. That it's a fairly that and the put function fairly powerful. Then of course we have put back, which basically could be used. This is a very powerful command where it could be used to read from the buffer of the keyboard. There's an actual memory aspect to the keyboard, which could then be queried by the machine when the machine loses track of the data. And for all sorts of reasons, power spikes, memory surges, all kinds of other stuff. Peek returns a character. Ignore skips the input. Then we have a number of character manipulation functions. We have to upper, which returns the uppercase version of a character. To lower, self-explanatory. If you know what to upper means, then to lower means take a capital letter and return the lowercase for it. Is upper basically is a Boolean, which checks to see whether is this a capital letter or is this a lowercase letter. Same thing with is lower. So returns a true or false. So it could be used in an if. And then of course, if it's a member of the alphabet, you have is alpha, which returns a true if it is a uppercase or lowercase letter, as opposed to any other characters or control codes from the keyboard. Now because this one was is alpha. The opposite of is alpha, oh, come on, is digit. Okay, so basically returns to see whether okay, so so we have is alpha, we have is digit, and then we have is alpha num or is al num, which basically says is it either a letter or a digit, but it can't be %, or the @ symbol or any of those other ones. Okay, so it's checking to see is al num, checks to see whether it's a member of the alphabet or whether it is a number from 0 to 9 from that singular character. Of course, is space, self-explanatory. Is punctuation, self-explanatory. Is print, returns a true if the character, if it's one of those, but basically if it's one of those alphanumerics as well as punctuation characters, right? And then is graph. Well, if you have, this helps you, and this shows you the breadth of C++ programming, particularly where you have, where you get into graphical displaying of pictorial pixels and stuff on the screen. So we have that scenario happening. And then, of course, last but not least, the control codes, Control Z, Control C, Control L, all those other ones, Control P, Shift P, all of those control codes that are used to control control certain functions of the computer that can be done by the keyboard. All right, so now we're gonna come back down. And So then we have instead of the C string, now we have the standard the standard string class. And so instead of the include of C string, now you got a whole other library where you have these strings that are treated as simple variables. And so we have in the simple or the standard C or in the standard string operation, this is more like if you've done work in BASIC or if you've done work in Fortran, where you have string S3 is equal to S1 plus S2. If S1 is first name and S2 is L name, then S1 plus S2 would be the first name plus last name. And there you could do things like S1 plus open double quotes, space bar, close double quotes, plus L name, and then you will have first name, space L name. And so where the standard C class, you can do some stuff like that. Okay. So you have this example of the use of just the include string, and then you have a string. Instead of the SHA variable, you use string, and phrase, then string, adjective, fried, and then noun, ants. And so the string wish, bon appetit. So we have phrase, I love, adjective, plus, okay? And then you have the space, plus noun, which is ants. Then you have the space, and so it says, I love fried ants, okay? As you can see, the classical string library is fairly straightforward, and a lot of people like to use it, but it is not as powerful as the C standard string library. And so, yeah, all right, so we got this stuff here, entering line, C line, get line. A lot of these get line put are holdovers from the original C language, which had a lot of commands in common with Fortran and some of the older languages. Okay. And then, of course, we have some operations, oops, where we have length and which returns the length of the string. Then you have at, and then you put whatever the character, and it will return the position inside of the string. So in this instance, you're not looking at the string as an array. You're looking at the string as a variable in and of itself. Okay, and so we got a number of functions within the string library. And so we have all of these here, but I could go down through, but I don't really want to because I know I'm running over you guys' time. Converting from a C string to a string object, and vice versa. So you can have a string variable, and it's perfectly legal to take a C string array and insert it into a classical string object and vice. But you cannot take a classical string object and put it into a C string array. Because like you said, the array has positions and the way it is set up. You must use the string copy command in order to do that. So you can do it, but like I said, you're going to need to use that command. Okay, so yeah, so we got the summary. C string variable is an array of characters with the addition of the null character at the end to set the ending. C strings act like arrays. You cannot assign or compare like simple variables. You have to have array functionality. There are two libraries. You have the C string and the string. I don't know why they have CC type, but anyhow. Both have useful manipulation functions. And then, well, okay, so they got this cin, get, and then we have the whole get line and other interesting stuff. So chapter 9, fairly interesting chapter. Tells you a lot of, okay, so what I'm going to do, I still hadn't decided on which one of these assignments at the end of chapter 9 I was going to give out. So, but yeah, okay, let me use, it's on page 394, question number 4. All right. There's a PDF. There we go. Let me see if I can. Yeah, all right. Write a program that reads in a line of text and replaces all 4-letter words with the word love. For example, the input string, I hate you, you dodo, should produce the output, I love you, you love. Of course, the output will not always make sense. For example, the input string, John will run home, will produce love, love, run, love. But basically, you're going to make use of some of those, you got to make use of some of those functions. Oh, and what I want you to do is I want you to write 2 iterations of the program. One using the C string, the other using the regular string variable, and see how you can get around the logistics to be able to solve the problem. Okay, so that's page 395, numero 4. Can I select these? Looks so. Okay. Let's copy and whiteboard. Okay. And save. Good stuff. All right. So, any questions? Okay, so with that, oh, sorry.
Would you put this up on the Moodle for us to access?
Oh, most definitely. That's why I'm putting it on as a whiteboard slide, so that when the video and the audio renders and I drop those on Moodle, this will be in that same folder. Fair enough?
Okay, thank you.
Okay. All right. So see you guys next week. Take care.